Run trace4. For this trace, we're going to use a different tool, this visualize tool, because it has a more complicated call stack going on. The visualize tool is especially handy for that. So we'll hit visualize and we go to this tool, and here's our code. As we hit forward, it shows us step-by-step the execution of the code. So we define the function f, we define the function g, we define the function h. Now we're going to print 1 plus h of 6. To do that, we go ahead and we call, see right here, h of 6. So we're in h with x equal to 6. And the first thing that's going to do is print f of x minus 3. To do that, it has to go into f. And x is going to be 3 because it's, when we call f of x minus 3 in h, x was 6. 6 minus 3 is 3. So now we have two different x's going on, and this picture captures this wonderfully. H has an x, and that's 6 right now. F has its own x, and that's 3 right now. These two variables seem to have the same name, x, but they're completely different variables that have nothing at all to do with each other. It's like if you had two people with the same name, same first name, that wouldn't mean they're the same person. These are just two different variables that happen to have the same, if you would, first name. You might, for instance, think of the function as the last name, if you would, of the variable. In any case, now we're in f, and x is 3, and we're going to return 4 times 3 is 12, plus 2 is 14. So we go ahead and step, and it's returning 14, which is going to come back out here, but now that f is done, you're going to watch this disappear right here. This is the call stack on this side, and when we go forward, f disappeared, and it printed 14, and there's your 14. Now x minus equals 1, which x? H is x, so we should expect this value to go to 5, which it did. Now we're going to print g of x plus x. Well, we're going to call g, and we're going to provide x of 5. Forward, now we're in g of 5. And that's going to call f of what? Well, 5 over 2, integer division, that's 2 plus 1, f of 3. Forward, f of 3. Now watch, this is showing us that right now we're computing h with x is 5. While doing that, we call g with x of 5, and while doing that, we have called f with x of 3. Now inside f, we're going to do 4 times 3 is 12, plus 2 is 14, and that gets returned back out to g. And now g has 14, and it's just going to return that straight back out to h. And h went ahead and printed that 14 plus x. X was 5. 14 plus 5 is 19. That's where this 19 came from. Now x mod equals 4. Okay? Well, x is 5. 5 mod 4 is the remainder when you divide 5 by 4, which is 1. So x should equal 1. Step, and there it is. X is 1. And we immediately went into g of f of x mod 4. Well, we want to call, when we call f of x, it actually did a couple things here. So f of 1 was up here. 4 plus 2 is 6. 6 mod 4 is 2, and now we're in g of 2, which is going to, of course, return f of 2 over 2 is 1 plus 1, f of 2. Well, f of 2 returns 8 plus 2 is 10. That 10 comes to g, which returns it back here, and then 10 over 2 is 5. So h returns 5, and we're going to print 1 plus that, which is 6. And there's our 6. And the program terminated. So we expect to see 14, 9, 6. Now, just for completeness sake, let's copy this. Let's go here, let's paste it, and let's run it, and we see 14, 9, 6.